Our next speaker is János Szendi-Varga from SEON. Will take us behind the scenes of building AI-powered products that actually work in production.
From idea to deployment, he will share the reality of designing, testing, and scaling AI features and what it takes to get from research to reliable results. Please welcome János Szendi-Varga.
Thank you. Thank you. So just a quick poll. How many of you shipped AI feature into production? Not so much. So let's see how we have done this. So my name is János Szendi-Varga. Actually, I started my career here in Nokia. So it feels a bit like coming home. So and there are still some people who are still working here, my former colleagues. So this makes this moment even more special for me. So yeah. So after Nokia, I spent some time at the supplier side. I have done a lot of projects for telco and bank sector companies, implementations in an agency. And later, I converted into the data world. I was graph technology consultant. I moved to the Middle East, where I worked for a company which later became a big AI company in the Middle East. And nowadays, they are the biggest player there. And after I came home, I started to work in the data industry. And in 2021, I started to work for SEON. SEON is a Hungarian startup. My origin goal was to build the data team who is responsible for machine learning and data functions of the product. So that's my career in short. And what about SEON? SEON, or SEON in a more Hungarian way, is a company relatively young. It was founded in 2017. Two Hungarian guys started a crypto exchange, and they faced a lot of fraudulent transactions. And they wanted to have a solution for fraud prevention, but in that time it was only available for bigger companies, for enterprises, for a lot of money, for banks, from the big players. So they decided to build their own solution, and later they pivoting into this space, and that was the main focus, to do a fraud prevention company. So during the years, we received a lot of investments from different kind of VC companies. We have a global presence with more than 5,000 clients worldwide. And we stopped a lot of fraud, and not fraud like in the previous talk, not telco frauds, but we are focusing on the financial fraud, something like that. So the R&D center is here in Budapest, more than 180 engineers, and the headquarters is already in the US, in Austin. So this is our company. And a little bit about fraud prevention or fraud detection. So actually, we provide API for customers to send in transaction, and we enrich the data with different kind of things. Collect data points, for example, for an IP address, we collect more information about the IP address, like geolocation, is it VPN or not, and things like that. And we do the same for all the data points. So we collect more than 900 data points for one transaction. And what makes SEON special is those data points are not third-party data. We not buy those data or collect them. They are all first-party data. So we have on our device fingerprinting solution, and we have our own web scraping solution to get social information from emails in real time from the web. So that's the high-level picture of the fraud prevention. So yeah, we have a lot of big customers as well from different industries. The biggest and the most well-known are Revolut or Wise, but we have customers from online casino industry, gambling, sports gambling, or I don't know, Tecovas, which is the biggest Western boot e-commerce web shop in the US. And we have KLM, Air France, and things like that. So big names. So let's start about the journey we had in the recent years. So in the beginning, so it was like that. Every company wanted AI, but they didn't know for what. So yeah, originally this main picture started with every CEO, but it was too offensive, so I cut it down. So every company wanted AI. We had the same situation. So yeah, for this purpose, yeah, a chatbot is an obvious choice, but yeah, been there, done that, but I don't want to talk about that. So we had to select some other functions where we can put AI into our product, and it makes the customer's life easier. So, and for us, it was more important because it was before our latest investment round. So all the VCs wanted to get into a AI story. So they wanted AI companies to invest in. So we had to show AI capabilities in the product. So we had to select some area where we can implement AI. So a bit about our product. So we are API first company. So software as a service, we have an API secure endpoint for companies to send in the transaction, and in real time they receive some decision about the transaction. So this is something which have to be very fast. So in a few hundred milliseconds we should answer. So this is not the latency we can deal with generative AI at the moment or nowadays. So additionally to that, we have an UI, because I don't know how familiar are you with fraud prevention, but the output can be something like that: approve, decline, or send into review or manual investigation. So we have an UI, an admin UI, where the fraud analyst can do investigation about the transaction which were declined or in a review state. So there are a lot of decision and investigation on the UI. So we felt that this is a place where we can implement AI functions to be helpful for the customers. So we decided, similar to the previous Nokia solution, we have a rule engine for the data points. So you can create rules for transactions, like, I don't know, if the browser language is different than the location of the IP address, then that's something you should consider as a suspicious or things like that. So usually our customers have a few hundred rules defined based on the data point. and their operation is always to maintain the rules. So it's a time-consuming and complex process, so they can use AI in that case. So they can express their intent in natural language, what kind of rules should be created. So this was one of the idea. And the other was filtering, because investigation is about filtering transactions, finding the suspicious data points and things like that. So there is a thing like called text to filter as well. So you can almost chat with the functions you have, and you can easily get to the result you want. So that was one thing we implemented. And the other thing we had, we have machine learning models as well, traditional, not generative AI models. They call it AI models, but they are machine learning models, predictions. So, for example, we take the data points, the 900 data points, and based on that, based on the label data, we create models, and we can predict the probability of a transaction, if it is fraud or not. But usually, if we say it's 70% the probability, the next question is always that, why? So most of the machine learning models, the better are black box models. So it's hard to explain the output, but there are techniques to do that. I don't know how many of you are data scientists, shape model evaluation, and things like that. So basically, you can give explanation to black box models and for that. For white box model, it's a decision tree, so it's explainable easily. So we have this black box model for each customers. We renamed it to AI Insight Score, of course. So we had to give explanations for that. So this is a place where we can use LLMs or generative AI very well. So generate explanations, and that is what is needed for fraud analyst, what is happened, why, and things like that. So we could tell them which data points caused the score goes up or down, so that's easy. So that was the other function we implemented, and we put it together into an AI bundle, and we released it with huge marketing campaign. That was the story. And this was the product management part of the story. Okay, the next one, the security and the compliance point of view of the story. So this AI revolution wasn't just happening in the product development. It was happened in the company as well. Everybody started to use AI tools from suspicious websites and things like that. So they just started to expose all the company IPs, data, everything on the internet, and we didn't know where they land. So yeah, so we realized that we need some structure for it. So yeah, it's not just technical decision, it's more legal or governance. So yeah, if I see only just the engineering organization, which is 100-some people, they started to use Cursor for code generation. They started to use Windsurf. We started to use Devlin AI, and we have a Google suite, so we started to use Gemini, and the list of AI tools started to grow, and it was like 100 different AI tools which was used by the company. So we had to create some structure, and we created an AI governance board It's a cross-functional team inside the company, product engineering, legal, security, and some stakeholders, and we had to create processes for AI usage. So we have to investigate every AI tool if it's good or purpose or not, and how our data is handled. And not just our data, because we deal with the customer data, which is more important to keep that safe. So yeah, for example, Devlin AI, they said it's a junior AI developer fellow or something like that. So if you share your source code with them, the junior guy can code something based on the prompt. It was not clear if they use our source code for the training purposes or not. So it was not clear. So in the first time, we were a bit skeptic about give the whole IP of the company to that shady models. So, for example, that was not used by the company anymore because it was not clear if they use or not. So,
sorry.
Yeah.
Now they are on windsurf. So
Yeah.
has anything happened in that regard?
I don't know. We canceled the usage of the Devlin AI. We use windsurf. So, yeah. So this was the security and compliance. So engineering point of view, it's the technical stuff, more exciting, especially for me. So we are a native AWS company. We don't have any servers. We are fully on Amazon cloud. And we call it transaction processing environments, one in the EU, one in the US, and later we implemented one in Singapore for APAC companies or customers. So this was important for us to keep the regulations, GDPR and different things. So that sort of thing. So we had to select an AI solution which is a good fit for our AWS. Yeah, it's an obvious choice that Amazon Bedrock is a collection of managed services for generative AI. So it was obvious to use Bedrock. And this way, we can keep the customer data inside our account, and it doesn't leave the environment we have. Because when the product managers came, they said, can we just call an API, open API, and we are done? Send the customer data through the open internet. It's not that good. So this way we can keep the data inside our backyard. So it was good. And it was, yeah, a good fit because integration is easy because all our stuff is in AWS already. So yeah, model selection. Yeah, Szilárd mentioned that in Bedrock catalog you can have thousands of models from different vendors, open models and things like that. So you can select based on price, number of zillions of parameters and things like that. For us, it was important the accuracy, the latency, and the regional availability, because that was not that straightforward, because I think Amazon is market-driven, so the newest models always come into the US first. And you have to push your account manager to give information about when this model will be available in the EU or in Singapore. And if you go further, the smaller markets, it will be later. So yeah, it's hard for a product manager to design a timeline when to release because you need the same functionality in that region. For us, the Cloud Sonnet was the selection, and because in that time it was new, it was well performant, and it was better than the 3.5. It was a bit slower, but it perfectly did the things we asked for it. So yeah. In Amazon, you can have some performance optimized model, which is faster, but they are not ever available for every models and for every regions. So it's, again, a complex choice. So yeah, we had to use AWS guardrails. They have good features like topic filtering, so you can filter out the nasty stuff and things like that. So you can have PII filtering and things like that. It's useful stuff, and it was easy to integrate. Yeah, we use the reg approach. So we have a lot of data. We can use them as examples for the LLM to generate context. For example, we have, I don't know, a few million rules already implemented by hand. We can use that to give the LLM examples about how to create proper rules for the product. So yeah, this is the technical component. So with this reg, you have to embed your data, which means you have to translate it into vectors. We use the Amazon Titan V2 embedding models. It was a well-performant, multi-language embedding model. So we can embed the information, store it. We have to use some vector database. We use Postgres in production. We have other databases as well, but for Postgres there is an extension, PG vector, which gives one more index, and you can get similar vectors. So yeah, and we implemented in Python, Kubernetes, all the fancy stuff in the cloud. Yeah, it's a bit different scale than the 6G network of mobile networks and things like that, but still we need scalable, performant infrastructure because we have, I don't know, 2 billion transactions per month. So it's not small data, but not infinitely big. So that was the engineering part. And the QA point of view, it was interesting because we quickly realized that traditional testing, like sending some input and expecting some output, doesn't work. So you can have different output from the same input based on the mood of the LLM or things like that, based on temperature and things like that. So we needed a mind shift there as well. We had to experience with the new way of testing the things. We have to create evaluation data sets, prompt fragments, snapshots, and things like that, testing the latency and things like that. And yeah, there are techniques we had to use, like LLM as a judge, but the most traditional way of human in the loop should be considered as well. So before shipping a model which create stupid rules is not good, so we had to do that in testing. So yeah, organization. So we had some learnings during this journey. So model availability, yeah, we didn't have control on that. We were not able to push Amazon to publish some models in Singapore because they don't care. So for example, the embedding Titan model, it turned out that it's not available in Singapore. And when we started the project, we had only EU and US. And during the time, we implemented another region, and we have to find some workaround this way. And the same with the cloud and the big models as well. One of the learnings we had, quota limitations. So it's strange. So Amazon has limited number of GPUs. And they have to distribute the GPUs based on the companies. And yeah, on the other hand, they have to provide business continuity to everyone. So they have quotas. So you can have, I don't know, 30 tokens per minute in the guardrail or something like that. They save they protect their infrastructure. So if you need more, you have to request, and you have to have explanation why you need more. But we hit a lot of quota during the testing, during the development in the smaller regions. In US, it's big because they have more GPUs, more customers, and things like that. And the rollout of the features is the same. They released first in the US and later in the smaller markets. So other learning was latency differences, because the first time they tried the product manager, it's slow. Yes, it's slow, because that's the AI technology nowadays. This is the inference time. So yeah, things like that. So one important learning was, it was mentioned many times during the day, you need AI observability. You have to know what to send, what is the response time, what was the token number, what was the price, and when somebody asks, I sent this and I received this, then you have to debug and find out the reasons and find out the way how to improve it. So you need AI observability. AWS has a preview version of AI observability tools, but they are working on that. It's not that mature, this market, but you can use open source version like LangFuse and others. So yeah, we had to pull that in. So, and sorry. Yeah. I was here. So yeah, learnings, AI development, it's a real cross-team effort. So you have to involve every company, and you have to plan with iterations, because it's not that straightforward. The first version will be good. So you have to keep in an iteration loop to make it better every time. So we had something in the works, so agentic. Agentic is important nowadays. We still don't have it in production because most of our customers don't use agents. So, but we can implement our own agent to help them. For example, fraud analyst agent, and they can fire some of the fraud analysts and they can use the agents or keep the cost at minimum. So that's the plan to use. We had some experimentals with MCP. There are concerns about security and authorization and things like that. It's still not mature to be able to put into production for controlled environment. So yeah, that's my summary. So when I look back, so the main lesson was that implementing AI, it's not just about technology. So it's just a tool, and you have to have strong foundations like data governance, scalable infrastructure, good APIs, and things like that. You have to keep in mind the security and things. And you need new processes for compliance as well. And it is as critical as the technology. So you have to adopt these things. And the people. So with this AI, innovation is boosted. So everybody can implement quick prototypes and things like that. So it can be a good tool to spark the innovation in the company, but you have to take the control. So yeah, so the key message already mentioned, AI is not just a feature, it's a capability your whole company should learn how to build it. So that's my talk. Thank you very much.
Thank you. Thank you very much. Oh, instantly hands, great. Okay, now that first question.
Thank you for the presentation. I have two questions for you. One in the reliability redundancy, which I can quickly reference to last month's AWS outage. That was massive. And how did they affect your SLAs with your customers? The second one, as you were hinting, AWS doesn't necessarily make all the models in every region or GPUs. You cannot go up as you wish. Possibly, correct me if I'm wrong, you're using reserved instances, not necessarily spot instances. That makes your cost way up. So how do you handle this price performance and reliability issues? I didn't see in your key takeaways. Thank you.
Yeah. So the first question, yeah, 2 weeks ago, there was a big outage in US East 1 region of Amazon. Our US environment is in that region. So, and most of the customers who used that service, they are using Amazon for their business as usual stuff as well. So the fraud prevention outage was the less concerning things for that. But yeah, we had to create a root cause analysis, and we have a list of corrective actions because we had some services, global services, which serves all the regions, and it was in the US and not by regulations, so we can prepare for that situation in the future as well. So that was the first one. Yeah, we had some outage as well, yeah. It's a dependency for us. Maybe multi-cloud is a solution for that, but we are not at that scale to build these things again in GCP or Azure. So the second one, yeah, AI observability tools are good for keeping the cost in control as well. So we would like to have the same feature parity. So we had to select the model which is already available in the whole region we have. So and nowadays we would like to use GPT-5, for example. It's not available in Amazon. You can use the open weight model from OpenAI in Amazon, but not the GPT-5. So either you wait some time to make it available. Actually, this week, Amazon announced a contract with OpenAI about, I don't know, $38 billion. But I think it's not because Amazon needs the models, because OpenAI needs the servers or something like that. So yeah, it was a long process to try out the different models. Amazon asked us to try out their models because it's cheaper and it's there. They don't have to pay royalty to OpenAI or Anthropic because of the cloud models. So yeah, it was a long process to select the best one which fits in price, in response time, and yeah, accuracy. And price was not a real concern because it's an investment in the company. So yeah, But there are some features where we use Cloud 3.5, and now they have some punishment. If you use older models, it's much more expensive than the newest one. So you are pushed to upgrade. Yeah.
Thank you.
Yeah, there is the next question.
Okay, I'm bringing the mic.
Yeah, as you mentioned, not all AI is generative AI, so my question is not about generative AI, but I'm curious how many transactions can you validate per second? And what is the average response time? I mean, your company, not you personally. And is every transaction sent by the customers to you, or there is some kind of pre-screening before the transactions are sent to you? Thank you.
Yeah, for the second question, yeah, it's up to the customer. So usually they send logins, withdrawal, I don't know, things like that, registration events, but it's up to them what to send to validate to us. Yeah, performance. We have an actual situation, but as the company evolves, we have to improve the performance as well. And we had to change the technology because sometimes we hit the limits. For example, one Postgres instance can handle, I don't know, 2 billion transactions, for example, and we have bigger customers already. So we have to change the technology as well. So we have a goal because, yeah, it's just a thumb number. We would like to serve a few thousand per second. That's the goal. We are not there yet, but this is necessary because as we grow, we are facing bigger and bigger customers. We want to enter into the enterprise market in the US, and it's not just a small company, or not like OTP is our partner or our customer as well. So, but we would like to serve 10 times, 100 times bigger banks or companies. So I would say, yeah, a few thousand per second, that's our goal.
Okay, thank you. Maybe one last question. Okay, I will bring it the microphone.
So you said that Amazon is pushing you to upgrade your models. My question is how difficult is to change your LLM models in your production or to rephase it? How many months or years are you planning with a selected model?
Yeah, so as a startup, we are going fast. So we don't plan for years, at least for decades. So yeah, my experience is that if we upgrade a model, then something will break in production. Even if the model is better, nicer, and more shiny, then that happens. So it takes time. So sometimes for us, it's easier not to touch. So if it doesn't break, don't fix it. So yeah, and we don't use AI in that scale. It would be painful for us because AI is just an investigation tool and it's not involved in the real-time traffic we have. So the traffic is generated by humans, not by the transaction systems. So we have enough money now after the investment, so it's not a concern now. But yeah, we have to consider this, keep the lights on, because sometimes they sunsetting the old models, they took away and you have to upgrade. So sometimes they have some grace periods. Sometimes you have to deal with that. It's not easy, but it takes time, and we have to do more shiny things. Yeah, thank you.
Thank you, and János. That was a real-world masterclass, how to turn AI ambition into real-world solutions. Thank you very much.
Thank you.
Thank you.